Introduction to Ad Hoc Networks. What is a network? Network is a series of points or nodes interconnected by communication path. Network can interconnect with other networks. These are called subnetworks. They are basically sharing of resources. Classification of network. A network without any base stations are called infrastructureless or multi-hop network. They are basically collection of two or more devices equipped with wireless communications and networking capability. They also support anytime and anywhere computing. Networks are classified into two topologies: heterogeneous and homogeneous. Heterogeneous, there are differences in capabilities, whereas homogeneous, all nodes have identical capabilities and responsibilities. It is an ad hoc network. It's self-organizing and adaptive. It allows spontaneous formation and deformation of mobile networks. Here each node host acts as a router. A router is a networking device that forwards data packets between computer networks. Routers perform the traffic directing functions on the internet. Data sent through the internet, such as the web page or email, is in the form of data packets. A packet is typically forwarded from one router to another router through the networks that constitute an internetwork until it reaches its destination node. Also, the ad hoc network supports peer-to-peer communication. It also supports peer-to-remote communication. It reduces administrative cost and also easy of deploying. These are the types of wireless network: infrastructure and ad hoc network. The first one, that is the infrastructure network, they are fixed and have wired backbone. Mobile communicates directly with access point. They are suitable for location where access point can be placed. One of the examples are cellular network. Then comes the ad hoc network, which does not have an access point. It is infrastructureless. They don't have a wired backbone. They are not fixed. They are suitable for location where there can no access point be. The operating principle of an ad hoc network. Considering the figure which has 5 node A, B, C, D, E. The figure depicts a peer-to-peer multi-hop ad hoc network. Mobile node A communicates directly with B with the help of a single hop when a channel is available. If channel is not available, then multi-hop communication is necessary. That is, it hops from A to D, from D to B. For multi-hop communication to work, the intermediate nodes should route the packet. That is, they should act as a router. For example, for communication between A, C, B, or D and E should act as a router. Bringing up on ad hoc networks. An ad hoc network begins with at least two nodes broadcasting their presence, beckoning with their respective address information. A beacon is intentionally conspicuous device designed to attract attention to a specific location. A common example is the lighthouse, which provides a fixed location that can be used to navigate around obstacles or into port. More modern examples include a variety of radio beacons that can be read on radio direction finders in all weather and radar transponders that appear on radar display. Here are broadcasting in the ad hoc network also acts like beckoning. They tend to attract all the other entities. They may also include their locations information if GPS is equipped. Beckoning messages are control messages. If node A is able to establish a direct communication with node B, verified by appropriate control messages between them, they update their routing table. Then, the third node C joins the network with its beacon signal. Two scenarios are possible. The first one is A and B try to determine if single hop communication is feasible or possible rather. And the second scenario is that only one of the nodes, that for example take node B, tries to determine if single hop communication is feasible and establishes a connection. Then the distinct topology updates consisting of two address and route updates are made in the three nodes immediately. In first scenario, all routes are direct, that is, from A to B, from B to C, and from A to C. Let's assume they are bidirectional link, that is, the communication takes place from both the ends. Topology update due to link failure. Consider there's a link failure between B and C. Mobility of nodes may cause link breakage, requiring route updates. Now assume link between B and C breaks because of some reason. Node A and C are still reachable via node D and node E. So old route between A and C was ABC is to be replaced by new route A, D, E and C. Here we see one hop is more than the previous, but the communication still exists. All five nodes are required to incorporate this change in their routing table. This change will happen first in node B and C, and then in node A and E, and finally in node D. Some challenges in ad hoc network. The first challenge is that host is no longer an end system. It can also be an acting intermediate system, changing the network topology over time. Potentially frequent network partitioning. Every node can be mobile. Limited power capacity. Limited wireless bandwidth. Presence of varying channel quality. When we say changing the network topology over time, it means that they are not fixed. So they keep on changing the network from one to another to the third one. So what happens is the wireless bandwidth gets reduced, and also the quality of the channel keeps on varying. Some more challenges in ad hoc network. How to support routing is the first challenge, having no access point. How to support channel access is the second major challenge. The third is to deal with the mobility, and then comes the conservation of power, and finally how to use the bandwidth efficiently. So these are the challenges in ad hoc network. Routing issues in ad hoc network. Routers are now moving. Since they are not fixed, link changes are happening quite often, because of which packet losses due to transmission errors. Even updates are sent often, so a lot of control traffic messages drop into the box. Then the routing table may not be able, or coverage. Routing loop may exist. Current wired routing issue uses shortest path method. Problems in power in ad hoc network. Power plays a vital role in the entities of ad hoc network since they are mobile. Ad hoc devices come in many different forms. Most of them are battery powered. Battery technology is not progressing as fast as memory or CPU technologies. Wireless transmission reception, retransmission, beckoning consume power. Quest for power efficient protocols. That is, they search for a power efficient protocol. Also, they search for a better power management technique. Application of ad hoc wireless network. The first application is military application. An ad hoc wireless network is useful in establishing communication in battlefield. Then comes collaborative and distributed computing, where a group of people in a conference can share data in ad hoc network. They also streaming of multimedia objects among the participating nodes. The third application is the emergency operation. They are useful in emergency operations such as search and rescue and crowd control. A wireless mesh network is a mesh network that is built upon a wireless communication and allows for continuous connections and reconfigurations around block path by hopping from node to node until a connection can be established. Issue in ad hoc wireless network. First and foremost is the medium access scheme, then distributed operation that is required. Synchronization plays a vital role. It is required in time division multiple access based system. Then comes the issue of hidden terminals that are the nodes from the sender. Exposed terminal are the nodes that prevent a sender from sending any information. Throughput, which is the maximum data that gets received at the destination from the sender at the correct point, that needs to be maximized. And then access delay should be minimized. Resource reservation is required for quality of service. Last but not the least, availability to measure the resource availability to handle the resources that are present in the network. And finally, real-time traffic support is needed for voice, video, and real-time data. Some more issues in ad hoc network are self-organization is required. That includes neighbor discovery, topology organization, topology recognition. Then the security. Denial of service, that is, you deny for any particular service that comes on your way. It also includes resource consumption. That can be classified into energy depletion, buffer overflow. Energy depletion is depleting the battery power of critical nodes. And buffer overflow is flowing the routing table or consuming the data packet buffer space. Information disclosure. A comprised node can act as an informer. They take in all the details and send to the other unwanted nodes. Interference. Jam wireless communication by creating data packets. These data packets can be empty or they can be filled with the unwanted data. They keep on jamming the communication so that the actual communication that was supposed to happen could be hindered. Issues in multicast routing protocol. First is the robustness. It must be able to recover and reconfigure quickly. That is robustness. Then efficiency. It should take a minimum number of transmission to deliver maximum packets. Then comes the control overhead. It demands minimal overhead. Quality of service. It has to support since it is very essential. Efficient group management needs to be performed with minimal exchange of control message. Scalability is again an issue. It should be able to scale a large network. Final issue is, as always, security, which is the most important. MANET. MANET is nothing but Mobile Ad Hoc Network. Here, the mobility of the entities or the nodes causes very frequent route changing. We see that there are two diagrams, there are two networks. Here the nodes keep on moving, keep on changing, causing a very frequent route changes. Mobile Ad Hoc Network (MANET) is a significant collection of wireless mobile hosts forming a temporary network without the aid of any established infrastructure or centralized administration. Significant differences of existing wired network includes wireless, self-starting, no administrator, cannot assume that every computer is within communication range of every other computer, and the possibility of quit-off dynamic topology of interconnection. There are four traffic types that are involved: unicast, multicast, anycast, broadcast. In unicast, there is one sender and there is only one receiver. In anycast, there is one sender and there can be any receivers. In broadcast, there is one sender and all the other nodes in the network act as a receiver. Finally, in multicast, there is one sender and there is selected many receiver. Problems in mobile ad hoc network. Mobility affects signal transmission. Mobility affects channel access. Mobility affects routing, that includes mobility-induced route changes and mobility-induced packet losses. Mobility affects multicasting. Mobility affects the application. Research in mobile ad hoc network. Variations in capabilities and responsibilities, variations in traffic characteristics, mobility model, etc. Performance criteria such as optimized throughput, reduced energy consumption, end-to-end delay, the lifetime of a packet. Increased research funding is the most significant research activity. So these are some of the areas in which a constant research has been done and it is still carrying on, so you can continue with them. Thank you.